Today we're learning about methods, how to package code into reusable chunks. This is how we avoid copying and pasting the same code everywhere. We'll explore how methods take inputs through parameters and send back results through return values. It's like a little code machine. And I'll show you how methods let us build complex programs from simple testable pieces. This is where programming becomes engineering. Imagine writing the same 20 lines of code in 10 different places. Now imagine you find a bug. You have to fix it 10 times. Methods solve this. Write once, use everywhere. Plus, methods give names to complex operations, making code readable. Instead of 20 mysterious lines, you see CalculateTax and instantly know what's happening. Okay, so here's what's happening. We define a method with its code, then call it by name. The code inside runs every time we call it. No copying and pasting. Methods have several parts: access level, who can use it; return type, what it gives back; name, how you call it; and parameters, what it needs. Don't worry about static yet, we'll cover that later. Parameters are how we pass data into methods. They're like variables that get filled in when you call the method. The values you pass are called arguments. Methods can return values or not return values. If you're not going to return anything, set the return type on your method to void. Void means returns nothing. If you're going to return something, you need to specify the data type you're returning. Those returned values could be captured in a variable by the caller to the method. You can have multiple methods with the same name as long as their parameters are different. C# figures out which one to call based on what you pass. This is called overloading. You can give parameters default values, making them optional. Callers can skip them, and the defaults kick in. Always put optional parameters at the end. Named arguments make method calls super clear, especially with Boolean parameters. Instead of mysterious true-false values, you see exactly what each argument means. This is that value versus reference thing again. Value types get copied into parameters. Reference types pass the address, so changes affect the original object. Variables declared in a method only exist inside that method. When the method ends, they're gone. Each method call gets its own fresh set of local variables. For simple methods that just return an expression, you can use the arrow syntax. Same functionality, just cleaner for one-liners. I love these for simple calculations. Each method should do one thing well. If your method is called save data and send email and log, you're doing too much. Split it up. Method names should be verbs that describe what they do. Calculate total is better than process. Get user is better than method 1. If a method is more than 20-30 lines, consider breaking it up. Smaller methods are easier to understand, test, and reuse. Be consistent with parameter order across similar methods. If one method takes Eden name, don't make another take name ID. If your method promises to return something, every path must have a return statement. The compiler will catch this, but it's a common beginner mistake. If a method needs more than 3 to 4 parameters, consider creating a class to hold them. Update user, name, age, email, phone, address is getting unwieldy. Methods that return data shouldn't change state. If it's called getUser, it shouldn't also update the database. That's surprising behavior. Methods let you write code once and use it many times. This is fundamental to avoiding duplication. Methods take input through parameters and send output through return values. This is how methods communicate. Each method should do one thing well. Small focused methods are easier to understand, test, and reuse. Good method names make code self-documenting. When you see CalculateTax, you know exactly what it does. Next up, we're tackling debugging, how to find and fix problems in your code. We'll use breakpoints, watch windows, and the debugger to see exactly what your program is doing. This is probably the most important skill for becoming a professional developer. Let's learn how to hunt down those bugs.